Hi guys, welcome to Module 2, Chapter 9, Geometric Shapes. My name is Sarah Vernig, and today I will be going over our 6 homework questions with you. So our first one is, what is the relationship of the measures of angle 1 through 12? Okay, so when we first look at this, it just looks super confusing. We have all these numbers, only 2 angles, and we just don't know where to start. Okay, so I recommend first is knowing some simple math vocab before you start. So a similar angle are the same shape, but they're not always the same size. Complementary angles have a sum of 90. Supplementary angles have a sum of 180 degrees. And congruent lines are 2 angles that have the same measurements. And that one is going to help us solve this, these missing measures of the angles. That one's going to be the most important one. So we're going to start where we see the angle 63. So knowing that they're congruent, so we know that angle 2 will also be 63. And we know that angles 1, 2, and 3 must add up to 180 degrees. No matter what we do, I mean, they have to add up to 180 degrees. So we can also see that there's the angle down here at the bottom by angle 6 that says 61 degrees. So if that one's 61, then angle 3 is 61. Now we can solve for 1. We take 63 plus 61. We add that together. We're going to get 124. We're going to take 180, subtract it from 124 to get 56. And that's what our angle is going to be for angle 1. Okay, so our first top half, that's all done. So now we can move on to our next one. So now we have angle 4. And it's kind of like what we did with angles 2 for the 63. So if 3 is 61, 4 is going to be 61. So now we have 2 angles out of 3. So to find angle 5, we just repeat the process of 61 plus 63, get that sum, which is 124, subtract it from 180, gives us 56 degrees. So knowing that, we can move on to angle 9. So angle 9 is going to be 61 degrees also because it is another congruent angle. So it's just they're right next to each other. They're, well, not next to each other. They're like diagonal across from each other. So that's how we know that they're congruent and they're going to have the same measurements. So to find angle 6, we're going to take 180, subtract it from 61 because that's the only other measurement we have. And that's going to leave us with 119. So angle 6 and angle 10 will both be 119 degrees. Okay, so now we have 7, 8, 11, and 12 left. And now we're starting to think, oh, wow, how are we going to solve these? These are not, what we're used to. Well, we can see that angle 1 is 56 degrees. By knowing that, we know that angle 12 is also 56 degrees. And another way to find angle 7 is, again, we have the 63 and the 61 degrees inside this triangle. We can pretend like this is just a triangle by itself. And again, if we add these up and subtract what we get, our sum, from 180 degrees, we're going to get 56 degrees. So we know angle 7 is 56 degrees. Knowing both of those will help us get 8 and 11. So for 8 and 11, we have 180 minus 56 gives us 124. So if 11 is 124 degrees, angle 8 is 124 degrees. And that is how we would find the measures of these angles. All right, number 2. How do you find the measures of angle 1, 2, 3, 4, 5, 6, 7, and 8? And again, we might look at this one, and it doesn't look as complicated as number 1 because we have a triangle, and we have another shape beside the triangle, so we're thinking, okay, well, this will be easier. It is a little bit, but only because we don't have as many angles to find. All right, so, and again, we want to make sure that we know what congruent is. Congruent angles are two angles that have the same measurement. And again, that's going to be our biggest math vocab that's going to help us solve for these measures. All right, so starting with, let's start with angle 4. So angle 4, we know is going to be 26 because angle B down here is 26. So when angle B is 26, 4 has got to be 26. Now to find, let's do number 6. To find number 6, all we're going to do is we know that C right here is congruent to 6. So 6 is going to be 74 degrees. To find angle 5, we just add 26 plus 74, subtract that from 180, and we're going to get 80 degrees. So that's number 5. Easy so far. Let's just keep on going. Okay, so our next one is, let's find maybe number 3. So we know that, 3 and 1 is going to be congruent, but 3 and 5 will be congruent. So we know that 3 is going to be 80 degrees. Now to find angle 2, we can take 80, subtract it from 180, which leaves us with 100. Oh, and number 8 is 80 degrees also. So there we have our math. And number 2 is 80 degrees or 100 degrees. And let's see, we have 7 and we have 1 left. So let's go ahead and do angle 1. So if we know that 3 is 80, we have 5 that's 80, we have 8 that's 80, we can gather that 1 will also be 80. Now 7, we know that there's 180 degrees right here. So we take 180, subtract it from 80, which will give us 100 degrees. And we have successfully found all the measures of the angles that this one has asked us for. All right, number 3. How do you find the measures in a concave polygon? And we'll look at this, and I mean, this one's tough. We see y, we see a bunch of numbers, and you just think to yourself, where do I even begin? Well, I can tell you. So what we first need to do is figure out how many sides we have. We have 8 sides, and you just count them, like this little bar right here is 1, and that's 2, and so on. Well, we have 8. So our formula is n minus 1 times 180. And n is the sides, how many sides you have in the shape. So 8 minus 2 is 6. 6 times 180 is 1,080. So now you're like, okay, well, we have that. What do we do now? Well, you're going to take that. You're going to set it equal to, we're going to add all of these numbers up that we have inside of our polygon. So we're going to have 3y plus 7y plus 7y plus 7y plus 3y plus 12y plus 3y plus 12y equals 1,080. Then we just solve. We solve for y. So we add up all the y values. We get 54y equals 1,080. Divide both sides by 54, which will give us y equals 20. You're thinking, okay, great. Y equals 20. What do I do with that? So what we can do is plug y in, or plug 20 in for y to find what measure every angle is. So for 3y, we're going to substitute 20 in. So it will be 3 times 20, which will give us 60 degrees. So every time we see 3y on our shape, we know that it is 60 degrees. Okay, 7y, we substitute 20 in. 20 times 7 is 140. So we have 140 degrees for every time we have a 7y. And now we have 12y. 12y, we're going to substitute 20 in. So 12 times 20 is 240. So that's all of our angles that we have. And I hope next time you have this problem, it'll be a little easier for you guys to solve. Okay, number 4. How do you find the measure of the interior, exterior, and central angles? All right, well, first of all, when we start with any problem like this, we need to make sure we know what the vocab is. So interior angles are on the inside angle. that is formed by two adjacent sides of a polygon. So anything that's on the inside, that's an angle. Like whenever these two lines meet, that's an interior angle. So you can kind of think of like interior of a house. Now exterior, we can kind of think of the same way. Exterior is going to be outside. So an exterior angle is the angle between any side of a shape and a line extended from the next side. So that would be down here. We have an angle outside of the shape. Now a central angle is an angle with endpoints, and it is located on the circle circumference and vertex located at the center circle. They are all congruent, and they will add up to 360 degrees. So right here's our central angle. Oh, and there's our interior angle. So to find it, we have a little formula. And again, we're going to add up the sides. So it's going to be n minus 2 times 180 divided by n. So we have 9 sides. So 9 minus 2 is 7. 7 times 180 divided by 9 gives us 140 degrees for the interior angles. We find exterior angles by dividing 360 by n. And again, n is our number of sides, and we have 9. So 360 divided by 9 is 40, and that's what degree our exterior angle is, down there at the bottom. Interior angles is the same way how we find the the central angle. Central angles are the same way. So again, we're going to have 40 degrees for our central angle right here. All right, and that's how we find those angles. Number 5, what is a tetrahedron? Okay, so we look at this big word and we're like, wow, we have no idea where to start. So let's break it down. Tetra means 4. So we have 4 faces or 4 equilateral triangles. It's also known as a triangular pyramid. That's what some people also call it. So this shape, and this right here is just a cube. But we're going to put this shape inside the cube to see if it touches any of the outside of the cube, or does it just touch the points. So let's get our shape in here. There's our tetrahedron. So we have it in here. We can see that it doesn't really touch the surface. It's just going to touch these endpoints at the corners of B, E, D, G. Did I get them all? I think so. Okay, so yeah, it just touches the outside of them. It doesn't really touch inside of it. Okay, and our next one, and this is very similar to what we just had. This is a tetrahedron. So if we think of this light colored triangle as the base, we could just kind of fold that up, and it's going to make a different shape, not just a flat triangle. And again, here's the lines where we would fold, and this is kind of where we wouldn't see. If it was solid, we wouldn't really see it. But so you kind of have to like picture it as a 3D model. All right, so what are these shapes? Oh my, we have 2 shapes over here. We're going to combine them to make one shape. So an octahedron, we kind of know octa means 8. So we can kind of guess from there what this is going to be. So an octahedron, it's going to have it'll be 8. It has 8 faces, 12 edges, and 6 points or vertices. So, and that's what this looks like right here on the right. So if we were to put these together, that's the shape we would get. All right, and our last one. You're thinking, wow, look at all those triangles. What are we going to do with all of those? All right, so this shape, we have 20, yes, 20 triangles. So 20 triangles, 22 vertices, and 36 edges. You're thinking, now what shape will that make? Because it's kind of hard to picture in your brain. You know, you have all these triangles and you're trying to think, what will it make? So let me show you. We get a shape that looks like this. So this is the result of our 20 triangles. And if you wanted to add them up, feel free. You can add them. They're all there, I promise. So that is our shapes for today. And I want to thank you for watching. And I'm going to end you with a joke. What did one wave or one flag say to the other? Nothing. It just waved. All right. Well, thank you for watching. And I will see you guys next time.